So this is the second video covering activity 4.5. We last left off completing problems 1 through 5, and now we're just going to finish up 6 through 10 and then move on. So in number 6, remember the zero product principle says that if this first term is A and the second term is B, that A times B, if it equals 0, either A is 0 or B is 0. So to find B here, that's easy, right? We can see that X equals -4 as a solution, right? Because if I have a -4 in for X, the whole piece becomes 0, right? If I put this -4 in here, I have -4 plus 4, which is 0, and 0 times anything will give me 0. But for the A term, it's not so simple. We actually have to set this piece equal to 0. So I take 3x minus 2 and set that equal to 0. Right, so I bring the 2 to the other side, and you see that we're going to be left with x equals 2/3. Right, so x equals positive 2/3 is a solution, x equals -4 is a solution, right? If I put in this positive 2/3 in for x, my 3 times 2/3 gives me positive 2, and then 2 minus 2 is 0, which makes the whole thing 0. If I put a -4 in for x, again, we get 0 here for the b term, which makes everything 0. Okay, so let's skip around. Let's go to problem 7, and then maybe we'll do problem 9 and 10. Okay, so problem 7, again, the first piece is easy to see, right? K equals -6. Right, if I put in -6 in for K, the first term is going to be 0. Right, so that's one solution. The second term, okay, well, it's because of the number in front of the K, we're going to have to solve this for 0, right? So, or solve this for K. So 5K plus 2 equals 0. I bring the 2 to the other side by subtracting 2 from both sides. And when I solve this for, oops, I wrote X. This should be a K. If I solve this for K, I'm left with K equals -2/5. Right, so that's my second solution. Right, so for number 7, what values of K will give me 0? Well, -6 would give me 0. Right, K equals -6 would give me 0, and K equals -2/5 would also give me 0. Okay, let's do problems 9 and 10. So I'm going to erase some of this because it's a lot of chicken scratch up here. So just hold on for one moment. Okay, so for problem 9, the 2x would be my A, and the 4x minus 7 would be my B. Right, so what value would make my A term 0? The only value of x would make the A term 0 would be x equals 0. Right, if I put in a 0 for x, well, 2 times 0 is 0, which would make the whole thing 0. Right, so x equals 0 is a solution. And then the second piece, for part B, what makes this part B 0? Well, if I'm not sure, I can take the 4x minus 7 and set it equal to 0. Bring the 7 over by adding. You get 4x equals 7, or x equals 7/4. Oops. Okay, so that's my second solution, right? X equals 7/4. Right, and for number 10, again, there's my A, my B. And remember, right, the rule says if A times B equals 0, right, either A is 0 or B equals 0. Okay, so for the first piece, yeah, X equals 0 is one of my answers, right? If I put in a 0 into this X, 6 times 0 or -6 times 0 is 0. For the B term, you have 2x plus 3, set that equal to 0. Bring the 3 over, so you get 2x equals -3. And you get left with x equals -3/2. Right? So that's your second answer. Okay? So that's how you handle these problems. Okay? So let's go to the next page. Right, so it says the zero product principle is only useful if the equation we want to solve is written in the form, some product equals 0, right? So here's a product. 6x times, right? The product of these two, a and b, okay? So I guess the question is, what happens if the equation is written differently? For example, what if it looks like, oops, let's get a drawing tool. What if it looks like this? All right, so now we're going to have to actually factor, okay? So before we solve this, let's just do a quick factoring tutorial. All right, they give us a quick definition. It's the process of writing a sum as a product. All right, so remember, it's almost like the reverse distributive property, right? If I were to ask you to distribute the A, right, you'd have A times B and A times C. All right, so we're just really doing the reverse of the distributive property. All right, so take a look at number or example 2, right? I like to think of this as, what is the greatest number that goes into goes into 9 and 6 evenly, right? So I believe the greatest number, the biggest number, the largest number that goes into 9 and 6 evenly is 3. So I'm just going to write the 3 here and a set of parentheses. So I factor out a 3. So now, whatever you factor out, you divide each term, right, by the 3, right? I factor out a 3, so I'm going to divide 9a by 3, and I'm left with 3a. I'm going to divide negative 6b by 3 to get negative 2b. And we've just factored that problem. All right, let's just take a look. Right, our answer is similar to their answer. Right, there's my answer. There's the book's answer. Okay? And then when you look at what they've done in terms of the distributive property, right, they're basically breaking down the 9 and 6 into factors, right? 3 times 3 is 9. 3 times 2 is 6. You can essentially factor out this 3 or use the reverse distributive property. And then you end up with this 3 times 3a minus 2b. Okay? Look at number 3, example 3. Again, I like to think of this as, what's the biggest number that goes into 4, 8, and 32 evenly? See, they made a mistake. They took out a 2, which is going to create more work for us. So I want to take a look at example 3 a different way. Right? So the biggest number that goes into 4, 8, and 32 is 4. All right, so I'm going to write that like that. Okay. Now, just like we did with the previous problem, if I factor out a 4, I have to divide each term by 4. Okay? So 4x squared divided by 4 leaves me with just x squared. And when I look at this next term, negative 8x divided by 4 is negative 2x. And the last piece, 32 divided by 4 is 8. Okay, and that's it, we're done. Okay, and if you look, that's what they eventually end up with down here. Okay, see, they took out 2 instead of 4, which would work, but the problem is this 2, 4, and 16 can be reduced further. So they pulled out another 2, and when you divide each piece by 2, you end up with this. Okay, and so the 2 times 2 gives you the 4. Okay, so I think it's always better to save you these extra steps, factor out the biggest number that goes into each term evenly. So in this case, it was the 4. All right. If I look at number 4, or their example 4, okay, it says we have negative 20x cubed minus 15x. In fact, I think I want to tackle this in the next video. So I'm going to stop here, and in the next video, we'll tackle example 4.